Here, I do research on a PhD on software security and with a special focus on web application security. And today I will talk about JavaScript malware. So, what actually is JavaScript malware? Just a short, quick starter. Basically, JavaScript malware is a buzzword created by Jeremiah Grossman in late 2006. And it describes a whole class of browser-based attacks that try to access and exploit internet resources. There has been a lot of ongoing research since late 2006, and I think we'll still see more results in the next couple of months. And what I think interesting about the stuff I will tell you about in the next 45 to 60 minutes is that if you look at the specs of HTML and HTTP and JavaScript and everything that is related to that, none of the stuff I will tell you about violates these specifications. So all the techniques I will talk about are actually legal, but they are still, to some degree, a threat to internal networks. And therefore, we don't need browser bugs to do interesting stuff with the web browser. Short agenda, I have to talk a little bit about basics, same origin policy and how to get around it, so that we are all on the same page. And then we have two large chapters in this talk, Intranet attacks in general, and a special focus on DNS rebinding, or also known as anti-DNS pinning. Then I take liberty and talk a little bit about client-side protection, especially local rodeo. That's the tool that me and one of my students developed, and then a short conclusion. Okay, the basics. I think most of you will already know this by heart, but anyway, the same origin policy is the one and only security policy that applies to web applications. There's nothing more, there's nothing less. It's not very sophisticated, but it is what it is. The same origin policy defines the access rights between two entities, two documents loaded from the internet and displayed in your web browser. Two documents or two active elements are allowed to interact with each other when the origin match. And the origin is defined by, let's see if I can work this. Oh no, I can't. By the protocol, so for example HTTP, by the domain, for example example.org, and by the port, usually port 80, but could be something different. If one of these three properties differ in the URLs that were used to get the content or that are used to display the web page, then the same origin policy is not satisfied, and if it's not satisfied, then those elements can't interact. So the same origin policy basically defines a sandbox, and actually it's a pretty good sandbox if you look at it. Web application or web page doesn't have any access to the local file system because from a web browser you need file protocol descriptor to get to the file system. So this is a violation of the protocol rule. You have no direct access to other web applications because they're hosted on different domains, and you don't have any access to other applications even if they're on the same server because they're run on different ports and use different protocols. So actually this should be a sufficient good sandbox, one would think. But there is a tiny but effective loophole in the same origin policy. And this loophole comes because JavaScript was just an afterthought after creating HTML. And HTML is the hypertext markup language, and the hypertext is the defining thing in HTML. Therefore, there are certain elements in HTML that reference elements that are hosted on network locations. For example, images reference images in script and iframe and style. And if the web browser tries to render one of these elements, it creates an HTTP request. The targets of these HTTP requests are not, restricted by the same origin policy. For this reason, we can create HTTP requests in this matter to cross-domain hosts. But let's see if this is on this browser. JavaScript can alter the HTML code of every web page it can write to, and therefore it can create dynamically images, iframes, style sheets on the run, and therefore is able to do indirect communication with cross-domain hosts using this technique. So by including an image from example.org, an attacker can create indirectly a communication to attacker.org from a web page hosted on example.org, for example. So what does this mean? The same origin policy should prevent cross-domain data retrieval, right? So what can we do with this indirect communication? We can do something that I call the basic reconnaissance attack. The basic reconnaissance attack has one purpose only. It allows the attacker to do a binary decision. Does the element that I reference with the URL u exist or doesn't it exist? The method is always the same. You can do reconnaissance in different elements. The attacker constructs a URL u that points to a host or to an image or to whatever that he wants to try find if it exists. Then he starts a timeout event t, that is rather important. And then he includes dynamically an element into the DOM tree that points to this external resource. And he outfits this element with two event handlers, the onload handler and the onerror handler. Now he has three indicators, the timeout, the onerror, and the onload, to find out what was the result of this inclusion process. And using these three event handlers, and depending on which element he tries to access and which element he used for this reconnaissance attack, he can deterministically conclude this host is up, this web application is running here, and stuff like that. The second thing to get around the same origin policy using this technique is getting partial write access to other domains. Or not really write access, but doing state-changing requests. This is a technique called cross-site request forgery. It's rather underestimated, but people start getting that this is a problem. And yeah, cross-site request forgery has like a million names. It has been called session writing, it has been called CSRF. Somebody now just recently announced that he starts to call cross-site request forgery unauthorized access. There are various different acronyms. But cross-site request forgery actually is a rather easy attack. It attacks implicit authentication. With implicit authentication, we denote all all authentication mechanisms that are executed by the browser without interaction with the user and without active involvement of the web application. So cookie-based authentication, HTTP-based authentication, client-side SSL, NTLM authentication, they're all executed by the web browser without the web application doing anything. And also the user is not really doing anything. The cookies are just put into the request by the web browser. Cross-site request forgery attacks these implicit authentication mechanisms by hiddenly creating or stealthily creating HTTP requests to web applications, and these requests are outfitted by the browser with the necessary authentication credentials. A really short example. So we have a banking application at bank.com, and the user authenticates himself because he wants to do some online banking, and after he did the authentication, he has the authentication cookie. And then he does some online banking. And then, oh, he receives an email and somebody tells him, hey, you should look at this. This is the most cute cat you've ever seen. And he's an internet user, so he's totally into cats. So he looks at the cat picture, and the cat picture is really, really cute. But what he doesn't know is that the cat has a little sibling, and the sibling is an invisible image, and the image has a URL that points to his bank. And as he's still authenticated with his bank, the image, the hidden image, is able to reference a state-changing URL of his bank, and the URL, because this bank was really careless, is doing some transferring money, a certain amount to a certain account. And as the user is still authenticated, and the cookie is automatically put to this request by the web browser, this might even succeed if the bank is really stupid. So banks are not that stupid, but other applications are. There were some really serious exploits in this direction. Okay, so much about the basics. And let's see how we can use these basics and these basic attacks I talked about in the intranet context. So I talked about implicit authentication. And if you look at your firewall and if you look at your intranet web servers, then you will conclude that the firewall actually is a means of implicit authentication. Every web browser that is inside the intranet is implicitly allowed to access the intranet web servers. Every web browser that is outside of the intranet, the firewall denies the access. So if the firewall is a means of implicit authentication, it is susceptible to cross-site request forgery attacks, isn't it? So this, we have the malicious host that's outside the firewall, and we have the web browser that's inside the firewall. By looking at the cat picture, the user that is inside the intranet implicitly allows the attacker to access internal resources by cross-site request forgery. Okay, so put it together. We allow JavaScript execution inside the intranet, and JavaScript can do the basic reconnaissance attack, and it can do some exploiting using cross-site request forgery. So this is not too good, is it? Okay, just to a little bit strengthen my point, the basic reconnaissance attack now in the realm of the intranet. For example, in this case, the attacker wants to know if at the IP 10.10.10.10 that he somehow knows is part of the intranet is hosted a web server. He includes dynamically an image into the source of the web page with the cat, and depending on which event it triggers, if there's an onload event or an on-error event, then he knows the host somehow answered, maybe with HTML data, maybe with an RST package. If there's a timeout event, then he knows, okay, the event has, the request has timeout, and therefore he knows either the URL exists or the host exists or it doesn't. But it doesn't really matter, does it? Because you use some obscure private IP that can't be found, IP space that can't be found out because you are behind a net. There's Java, and if your browsers allow your users to use Java, then you have a small problem because Java has sockets. JavaScript doesn't have sockets, doesn't know about IPs, Java does, because Java has a little bit different same origin policy. And the socket object is not only settable, it's also readable, while the communication is still restricted to direct communication attacker org. The attacker is not really interested in the target of the communication. He knows which IP attacker org has. He's interested in the source of the communication. And therefore, he creates a socket communication and looks at the local address of the host address. And this is the IP address of the local browser. So therefore, on modern browsers like Firefox and Opera, it's even possible without starting an applet by using Live Connect that allows JavaScript to create dynamically or instantiate dynamically Java objects. Good, so now the attacker is able to find out the IP address and he's able to do a series of basic reconnaissance attacks. So now he can go through the intranet, through the IP space, looking for internet web servers. I don't go into much detail now because there are subtle differences on which event to use with which elements. So with iframes, you don't get on errors, but you get better fingerprinting of a service and stuff like that. I think if you're really interested, you can look it up on the internet. These slides have a rather large reference section. But I have a small demo to prove my point. So this is hosted online server at database.net, and this is a really dirty hack, and you can look at the code, but you can do it better. I guess I just wrote it yesterday because I thought maybe it's interesting. And also, maybe I can't even access it because my internet is not working. What do you say? That would suck. So I have an IP. Okay, we wait 1 more minute, then I go on with the presentation. Maybe one of the organization stuff can get me cable internet or cable-based internet, not airport internet. Okay, never mind. Let's go back to the presentation. Maybe you can look at the demo at the Q&A, or maybe not. So we can do, when the attacker knows which IPs, which local IPs host internet web servers, he can do even more. He can try to find out what servers there are. So if it's Apache or Internet Information Server, you can try to find out if it's maybe a home router that is doing some some work on this network, or if there is an internet server, maybe he can find. He wants to know if there's a MediaWiki or WordPress or Skrillmail. Depends on which one has the best possibility of exploiting. This can all be done with the basic reconnaissance attack again, using iframes and well-known URLs of those your services that you want to fingerprint. And if you really know what you're looking for, then the script element is rather powerful, because it doesn't only give you an indicator that there was an error if you include something, but also it gives you rather explicit error messages. And depending on which HTML code you try to include in a script context, you get different error messages. So you can build up, with some indicators, you can do a rather profound database on stuff you want to look for in the internet. There's a showstopper, and this is HTTP authentication. So if the user that is victimized in this attack encounters a web resource that is protected by HTTP authentication, which the user hasn't accessed recently, then the browser will pop up inadvertently authentication dialog. And even the most unsuspicious user will be startled, I think, or surprised if some cat picture asks him for his internet password. So this is something the attacker wants to try to avoid. There are techniques around this. The trick behind this is to create HTTP requests that doesn't respond with 401 codes or 200 codes, but that fail before being processed by the web server. So the web server sees, okay, there's an HTTP request, but I can't do anything about it, and it returns with a 500 error code. This can be done with two tricks. Either you can use incomplete entities that cause most web servers to fail. If this doesn't work, some browsers don't do this, for example, Internet Explorer 7, then you can use very, 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 very long URLs. Then you also get a 500 error code. Please note, this breaks fingerprinting. So the attacker has to decide if he wants to really be stealthy, if he wants to doesn't want to be recognized at all, or does he want more information? But we come on back later. So the attacker is now able to locate the web servers that are hosted in your intranet, and he's able to do, if he has a sufficient big enough database, he's able to fingerprint what actually is in your intranet. And therefore he has a rather good starting point for successful cross-site requests for details. Then if you look into intranets, and I think you will all agree, intranet servers and internet applications are rarely as rigidly patched as comparable applications that are reachable from the outside. Because who should attack you? Why should I even change the password of my home router? Because only my wife and my kids and I are able to get to the admin interface. I trust them. Or why should I patch my WordPress installation that I use for internal communication? I trust my employees. So I still want WordPress 2.0 that has some serious remote code injection vulnerabilities. But as the attacker now is part of Intranet and part of this trusted zone, he can use old off-the-shelf exploits, and in many cases should be able, from within this web page, using cross-site request forgery, to attack your intranet servers. There are limitations. The attacker works with timeout events, and timeout events take time. So every timed out event, if you want to, so the longer the timeout, the clearer is the picture, because these techniques are obviously bound to have false positives, because everything is a little bit fuzzy. We don't really know what error occurred or why the server didn't answer timely. So we have to deal with rather large timeouts if you want to be secure or sure that we know what we're doing. And the attacker can do some parallelization, can request more than one element at a time, but most operating systems, and Windows is the most strict one, they pose limits on the number of connections. So probably looking at cat pictures is not the way for the attacker to do, but a cat video, for example, should do the trick. So if you can trick the user to stay at the web page for about 3-4 minutes, then he should be able to do some decent reconnaissance on 255 hosts, stuff like that. There are also port restrictions, so while port 80, port 443, and port 8080, for example, are all accessible, it shouldn't be a big problem. There are other ports that are restricted. Okay, there are further attacks that I talk about. There are fingerprinting and attacking attacks on non-HTTP services using multi-part forms. The papers are in the references of this talk. And there are a lot of attacks that don't require JavaScript, but as I'm talking about JavaScript malware today, I don't cover them. You don't have to invent your code or invent your code yourself. There are convenient attack tools already available on the net for free. My favorite one is Beef. It's called Browser Exploration Framework. It's a one-line cross-site scripting, one-line JavaScript include that you can use in cross-site scripting attacks, which is rather powerful. And there's also Backframe, which I didn't look at in detail. Good. So this were the HTTP-based simple attacks. Now we go to DNS rebinding. DNS rebinding is also an attack that has had a lot of names. It used to be named DNS spoofing back in 1996. Then somebody called it quick-spot DNS. Then lately, I called it anti-DNS pinning. And right now, people call it DNS rebinding. I think DNS rebinding is the final name, so forget all the other names. The attack itself is rather old. It was invented to attack Java applets. And it is based on a DNS server that is controlled by the attacker. And the attacker assigns internal IP addresses, for example, 10.10.10.10, to DNS names that he controls dynamically. And we see how this works out. Okay, again, our scenario that we talk about all the time today. And the attacker again lures the victim to execute some active code inside the intranet. And the attacker hosts his content on attacker.org that is assigned to 200, 200, 200, 200. Now, before the hidden JavaScript does its magic and tries to access the intranet server, the attacker changes the binding of attacker.org to 10.10.10.10. And then the JavaScript tries to access the intranet host. But now the JavaScript doesn't use the IP anymore, it uses attacker.org, because attacker.org now points to the intranet. And now attacker.org served a web page that tries to talk to attacker.org. Therefore, the same origin policy is satisfied. And our malicious script has full read and write access to the server and also is now able to leak the complete content of the server outside to the attacker. As this attack is rather old and has been rediscovered at least 3 times, there obviously are countermeasures. The countermeasure is called DNS pinning. DNS pinning is a technique that forces the browser to keep the mapping between the DNS entry and the IP address for the whole lifetime of the browser session. This is not really something you want, because it violates RFC, it breaks dynamic DNS, it breaks some load balancing techniques, it breaks some fail-safe techniques, and all this stuff is even worse because right now, or nowadays, our browser sessions last forever. I never shut down my computer. I put it to sleep. And I never quit my browser. I put my computer to sleep. So my browser sessions last about 2 or 3 weeks. So if I want to access some dynamic DNS or some load balancing stuff, I might have problems with strict DNS pinning. And for this reason, DNS pinning wasn't really good implemented in all major browsers. They pretended to do so, and everybody believed them. But all the major browsers, so Firefox, Opera, and Internet Explorer, are susceptible to breaking DNS pinning. And rather simply, the trick is that the attacker.org, after delivering the malicious JavaScript in the first web page, or first step, after the JavaScript has delivered, the attacker pretends that the host doesn't exist anymore, or the web server has shut down. So he doesn't accept any more connections from the victim. Therefore, the victim browser thinks, okay, the web server is dead, and tries to refresh its DNS cache. It always works reliably, and therefore the attack works again. This is something we found out last August, and it still hasn't been fixed. So I'm not sure if there actually even goals to fix this. Maybe we can talk to Vinod Snyder. She's here tomorrow, the security chief of Mozilla. I would be interested in what they are planning on. Okay. Are we able to see that a DNS rebinding attack has happened in our intranet? Actually, we might be. because there's something that's called the host header, and the host header is set according to the URL that is used for the HTTP request. The host header is set automatically by the web browser, so the attacker can't really do anything against it. And the host header is set to attacker.org because the web browser tries to access attacker.org in this request. So if the web server just looks for mismatching host headers or uses a virtual host to host the interesting content, you should be somewhat safe. That's been something called anti-DNS spinning, a word created by Robert Hansen, describing attack methods that were available for a short time because of browser bugs, implementation bugs. XMHTTP request and Flash both were able to set arbitrary HTTP headers. Both of these issues are fixed. So I think there are still some Internet Explorer versions out there that allow this setting of arbitrary headers on the host header, but usually we can consider this prefixed. And therefore, we should assume that the host header is a good measure to detect DNS rebinding. But it's not that easy. We don't only have JavaScript in our web browser running. We have a little bit more. We have also Java usually, and we have Flash. And do you remember Live Connect? I mentioned it briefly. Live Connect is a possibility for JavaScript to create dynamically Java objects on the fly. This is the code to create a socket object. So what happens if we create such a socket object after the rebinding has happened, after the attacker.org is set to 10.10.10.10? Obviously, the JavaScript virtual machine has its own pinning table. It's older than the one in the browsers, and it has a somewhat different policy. And the Java virtual machine for this special context built up by the web page hasn't even started up before the rebinding has happened. And for this reason, the Java runtime only sees the new pins 10.10.10.10 to attacker.org. So now the attacker has TCP sockets. And even if Java is not available, there's something called Flash, and Flash 9 also has sockets. They are not as powerful as the ones Java provides, but they are useful. And okay, Flash provides sockets, and Flash does not provide pinning at all. I don't know when they want to implement that. I get referrals from the Adobe Intranet at my web pages a couple of times for my anti-DNS pinning advisories. So they might fix it, but right now the issue is still open. And with Live Connect and also with Flash, rebinding attacks are also faster than JavaScript, purely JavaScript stuff. Okay, so what can we do if we have sockets? The nice thing that we can do, or the attacker can do when he has sockets, is he can recreate HTTP from scratch. And now he doesn't only can set up, he can do everything, and he can set now arbitrary headers again. And now he's able to set the host header that the web server expects that there will be. And he's even more powerful. Now he can get rid of HTTP authentication problem that I talked about earlier in a better way, because he has a socket connection, so the browser doesn't even see that there's a 401 status message, and for this reason there will never be one of those pop-ups. And now he can, the attacker can send a request after request after request, iterating through authorization headers that he puts on the fly, and he can do password brute forcing. And so if you have only weak passwords on your HTTP authentication protected intranet hosts, this might be a problem. There's a lot of more you can do with sockets. You can access other protocols, you can access binary data, you can do pretty much everything, but I can talk about this today. Billy K. Rice is going to give a talk on this subject tomorrow, so I urge you to go there. There is he, Billy. Cool. Okay, now to something more positive, to protecting this stuff. So as I was involved in evolving those attacks, I kind of felt guilty, and I thought we should start thinking about how we can protect ourselves against these attacks. And me and my student Justus, we thought about, okay, what can we do? And we decided to start at the client side. And the first question I want to answer is, why did we start at the client side? Why don't we try to enhance our servers to protect this stuff? And the answer is as follows. The server only sees correct HTTP requests from intranet hosts that he trusts. If the attacker is really good and really stealthy, there's really not a lot that the server can conclude, because there are only two indicators that the server could employ: the referrer header and the host header, because the referrer header might be set to something external attacker org, and the host header in a DNS rebinding attack, if the attacker only relies on JavaScript, also is mismatching. But there are various techniques to get rid of that work reliably. And as I told you already, with using Java objects via Live Connect, or using Flash, we can create our own host headers. So everything is useless. Therefore, we implemented a small Firefox extension called Local Rodeo. And Local Rodeo has a rather simple approach to do protection. It creates a new trusted zone, the local zone. And now you have local pages. Local pages are pages that are hosted on IPs that belong to your intranet. And you have remote pages, that is everything else. And only local pages are allowed to create dynamically more requests to local resources. Very simple example. First, we have some cat pictures on the intranet, and if this page is labeled local because it was delivered by an internal web server. If this page tries to load dynamically some more data from the internal web server, it's a load because it's a local page. If the attacker tries to pull this attack, his website obviously is tagged as remote because 200, 200, 200, 200 is not part of the intranet, and therefore all further requests to internal resources are blocked. Okay, we also protect against DNS rebinding. As we monitor web pages and put a label to them, remote or local, we are rather easily can detect if a web page, a domain name, changes its status from remote to local. And this is an indicator for a DNS rebinding attack. And so this is, from our point of view, rather easy to stop and to spot. We are not foolproof. While it works for rather simple networks, you might have problems configuring it completely for all your hosts, because sometimes there's a gray area where host is part of the intranet, but also hosts a couple of resources that should be accessible from the outside. So this is a problem you have to think about and maybe change your networking policy. And also there's a problem with large companies. So if you're Siemens and you have like 10,000 hosts in your net, do they all trust each other? Is this one big intranet, or how do you treat different network segments? So Local Rodeo is the first approach to do this, but I think it won't be the last one. We have rather good and rather easy protection against the specified attacks that I talked about today on simple networks. It works out of the box with private IP ranges. But as I told you, complicated network problems, network setups might make problems. And also, there's no protection at all against attacks that rely on Flash or Java, because Firefox extensions are basically JavaScript. They can only work on the stuff that is available to the browser. And the Flash plugin and the Java plugin are external entities to the browser, and we don't have any means to do something against this. Okay, the implementation is hosted at that URL. I invite you to try it out and send us bug reports. It's still in beta. This is mainly because we are rather lazy and not the best programmers in the world. But it's open source, and so if you want to contribute, I would really happy to welcome you. And also, the NoScript developers announced that they will adopt the stuff that Local Rodeo does in their next major release. So maybe we just all have to wait for NoScript for the next release, and then we will be protected, because everybody should use NoScript anyway. And there are more approaches to countering DNS pinning. People at Stanford are doing really, really good work in this direction. And they proposed a couple of interesting countermeasures. And one I really like, it's a firewall. And the firewall has only one purpose. It monitors DNS traffic. And if it encounters DNS traffic that tries to bind an external domain name to an internal IP address, this DNS traffic is dropped and not allowed. I think this is a rather effective and good countermeasure against DNS pinning or DNS reminding attacks into an internal network. We have source code on the website, so check it out. But this does only protect against rebinding attacks. So the basic reconnaissance attack and cross-site request forgery and stuff like that from the first half of the talk is still possible. The people at Berkeley also think about protection mechanisms. The link to the paper is in the references of this talk. Okay, let's conclude. What haven't I told you? Because I told you quite a lot of stuff, but there's still more that I didn't cover in this talk because time is almost over and because it's not really focus of this talk. There is a whole class of attacks that don't rely on JavaScript, and this class recently is growing because people start looking at cascading style sheets and what can be done with them. So ping sweeping and stuff like that is rather easy to done without JavaScript at all. And if you take stuff that Ed Felden invented back in 2000, timing-based reconnaissance attacks, then you are pretty powerful without JavaScript. There's a whole class of privacy attacks that don't aim at finding out about the internal network, but try to find out who's using the browser and what are his characteristics. So there's a lot you can do, including finding out what you have recently searched on Google. And there's a big class, and I think this is the class that worries me sometimes the most because it's the hardest to work against. It's using the browser as an attack proxy. So there has been shown that DNS rebinding attacks can be used to do click fraud. Has been shown that just JavaScript using some external mechanisms like Google Translate can be used to do audits to third-party websites. So your browser is now scanning Google for cross-site scripting, SQL injection problems. And there has been shown that websites can be used to help worms to propagate by identifying victims. So I think in this area we will see a lot of action in the next 12 months. Yeah, check out the references. Short summary, I have shown that a web page that you look at can find out which IP your web browser is hosted on, can do a ping sweep to find out which IPs web servers, can find out what these web servers actually are, so if it's Apache or a home router, if it hosts WordPress or something else. Depending on what he finds out, he can use cross-site request forgery with well-known exploits, or he can try to break DNS pinning to find out what is hosted if he wasn't able to do it for him. And even if you don't look at cat pictures, always remember this is JavaScript, and therefore it's a potential payload for cross-site scripting attacks. And if you remember the semi-worm that invaded or that infected more than 1 million MySpace profiles in less than 24 hours. So this malicious code has been executed at least 1 million times in 24 hours. And if you have a rather large company, it's probably possible that this code has been executed in your company as well. So I wouldn't not undermine the problems. I don't want to exaggerate. They are what they are, so it's not the end of the world, but something you should think about. Okay, if you have intranet servers, try not to host, at first patch your intranet servers to the highest number that you can find, try to make them as secure as your external servers, and also don't host any classified information without explicit authentication. So don't rely on the firewall, and also don't rely on cookies or HTTP authentication alone. Try to do something like form-based authentication or URL-based authentication. It's really important if you want to get rid of some of the cross-site request forgery stuff. On the client side, disable Flash now, and probably disable Java as well. Then you should be rather secure against the master rebinding stuff, and also the attacker is not able to do his first step to find out which IP is used to host your web browser. So this should help. And if you use NoScript or local rodeo in connection, then it's not as bad as it could be. There's still the JavaScript less stuff. With local rodeo protects against the JavaScript less stuff, but we will see. Okay, from a more academic view, because I work in academia and this is part of my PhD research, the same origin policy is completely insufficient. It's not sophisticated enough, but also at the same time, it's too strict for some applications. And yeah, we should get rid of it and find something better. And also DNS pinning is not a good countermeasure against these attacks. DNS pinning should go the same way the same origin policy should go. Because relying on DNS as a security property is not a good idea. The DNS entry is not controlled by the application at all. It's controlled by an external entity that is not even controlled, that can be set by anybody. So the web application itself should be able to set its security requirements, and this can't be done via DNS. Yeah, and soundly doing this on the client side alone is not possible. Doing it on a web server is not possible at all also. So we have to figure out a way how browsers and web servers can work together to get rid of these problems. Yeah, and this is the direction I think future work should go. So this was my talk, and I don't know, shortly show, I think I'm supposed to have Intranet now. How much time is left? Oh yeah, okay, I show you very quickly. I tried to show you the demo because I stayed up all night yesterday to write it, and then one second. Okay, let's try again. No, forget it. It's not meant to be. If you're interested, come to me later, and then I'll show you the demo 101. Okay, questions, if there are any. If you want to win the Panda, won't you? If not, I keep it. So either I didn't make sense at all, or it was boring, or I answered all the questions, but either way. Oh, there's a question. Oh, yeah. Check it out. So much stuff to read.
I just want to ask if, regarding about the countermeasure of this, I mean, based on your summary, right, you say that in the end you need to implement this policy from the server side. So based on, I mean, from my understanding, for Apache, they do offer some sort of like a third-party, let's say, plugin like mod security. Will it minimize the risk of like this type of JavaScript attacks?
I think I didn't understand the question. Sorry.
Okay, I'm saying that, okay, if you're saying that basically JavaScript attack is a web-based, right? So basically the firewall will not affect much as it has, it will allow port 80 to go through. So to think of it, right, is it, I mean, based on some of the plugin like Apache server, right, they have some sort of like external module known as the mod security, which, okay, would it be more effective, or it can be implemented on other servers? So this, I just want to know, would it be effective in using mod security, right, to prevent such attacks?
I haven't really looked at web application firewalls as it's provided by mod security. I can imagine that mod security is powerful enough to look for mismatching host headers. So if your clients disable Java and Flash, so if you only have JavaScript-enabled web browsers, then you should be able to do a mod security rule to look for mismatching host headers to find out if a rebinding attack hasn't happened. And if you only accept messages with valid referrer headers, you might be able to do something. But still, I think this is a really, really patchy, this is not a complete solution. So you might be able to get some of the problems, but you won't counter the whole threat. But a good question. Thank you. Okay, everybody, I say it again, tomorrow, Billy K, DNS pinning or anti-pinning or rebinding with Java applets. I'm really excited. I haven't seen what he's doing up to, but I think he has great demos. Okay, thank you. Yeah. Come on up. You're